Yes, I will be discussing three nonlinear resistance technologies and their applications. The first technology I want to talk about is the resistor, and the main application is to protect circuits from voltage surges and spikes. It can be found in many surge protectors and electronic devices. The idea behind it is that the resistance decreases with increased voltage. And it's ideal for transient voltage suppression. And for about the thermistor, it depends on the temperature, and it's used in temperature sensing and control as well. It can be found in thermostats and temperature sensors as well. And the idea behind it is that the resistance changes in a non-linear fashion as the temperature arises. And for the last part is the photoresistor, which is an LDR. And it's really common in light sensing applications, whether it's street lighting or photographic meters. And the idea behind it is that resistance decreases with increasing light intensity. So that's it for the nonlinear resistance technologies. Moving on, we will be discussing practical codes used for capacitor values. So the main idea we will talk about is the 3-digit code, which is one of the most common codes used for capacitance. As we can see, the ceramic capacitor here, it has the first number, it shows the max voltage which the capacitor can handle, and the second number is the capacitance. We can see that the last number is actually the multiplier for the unit, and the last is the tolerance. And as we can see in this ceramic capacitor, it's non-polarized, and this is the symbol for the non-polarized capacitor. Moving on. Yes, this is the letter code for expressing tolerance in capacitors. It has many ideas, but for example, it shows how much tolerance exactly for the voltage. For example, J it represents an increase or decrease in 5% for the voltage, and K is 10% and M is 20%. It's not arranged in an alphabetical order, but this is you need a table to actually understand the tolerance for the capacitor. Yes, and the last code is the voltage rating code, and for some capacitors, when it's displayed in large marking, it only shows what is the maximum range that the capacitor can actually handle. So, for example, if 25V is written in a large marking on the capacitor, it means that it can only handle up to 25 volts. And yes, that's it for the capacitor.